Okay, so today we're going to do 5.3 elimination using addition and subtraction notes. Elimination is basically another way for us to solve systems of equations. We did graphing and we've done substitution, so elimination is another process. If you have your notes that you've printed off from Google Classroom, we are skipping over this chart. And we're going to skip over this section and we're going to go right to the bulk of the problems, to this section right here. So if you have your notes in front of you, you're going to go to problem 4. So elimination is going to do exactly what it says. We're going to eliminate one of our variables and then use that to solve. So what we're going to do, the easiest way to do this, we're going to create kind of what I call a gigantic addition problem. So we're going to combine our terms together to see if we can solve for x and for y. The upside of doing this with this one, if you'll notice, we have a positive y and a negative y, and those would actually cancel each other out if we did vertical addition. By adding our two x's together right here, we end up with 2x, and then negative 4 plus 2 would be negative 2. So our x value is going to be negative 1. So we know x, what we need to do now is find our y. So to do that, we can substitute it in either of our equations up there. I like to circle the one that I use so that I don't look up there later and then fill in the wrong things. So I'm going to plug it in. Our x plus y is negative 4. We found out that x is negative 1, so we're going to put that right in there. Plus y is negative 4. So to solve for y, we're going to add 1 to both sides. So y ends up being negative 3. So x is negative 1, y is negative 3. So there. So our common solution for those two equations is when x is at negative 1 and y is at negative 3. So go ahead and do the next one that's on this page. I think you'll kind of get the drift after this. So our 3a added to our negative 3a, those will cancel out. And then we have negative b, which is like negative 1b. So if we have a negative 1b and we add it to negative 2b, we get negative 3b. So negative 3b is negative 9. So if we divide both sides by negative 3, we end up with b equaling 3. So now we're going to pick one of those equations. I'm going to go ahead, it doesn't matter which one of those two. I'm going to pick the top one. So we know b is 3. So we're going to plug in 3 into b. So 3 is going to go right there and then equals negative 9. So now we're going to add 3 to both sides. If we add 3 here and add 3 here, we end up with negative 6. So a is going to equal negative 2. So our common solution for this is when x is negative 2 and b is 3. So I'm going to go ahead and skip a few here, and I'm going to go to number 8. So number 8, if we do the same thing that we've been doing, 6x and 6x are so close to being able to do that. If I can make one of those 6x's into a negative, I could use elimination for this one. So what I'm going to do is take, it doesn't matter which one, but I'm going to take this equation on the bottom and I'm going to take everything times negative 1, which basically would make everything its opposite. And then I'm going to go ahead and combine those in my very large addition problem. So now my 6x and my negative 6x are going to wipe each other out. 5y and 7y is 12y. And 20 plus 4 is 24. So I'm going to divide both sides by 12. So we end up with y equaling 2. And then I'm going to go through that same process again where I pick one of those equations. I'm going to pick this one where I haven't really made any changes to that one. So we have 6x plus 5 times whatever y is. We found out that y was 2. And that should be equal to 4. So we have 6x plus 10, that equals 4. And I'm going to subtract 10 from both sides. So I end up with 6x equals -6, so that means x would be -1. So my solution for those two equations is -1 is x and 2 for y. Now keep in mind too, you're going to have you could have a situation where you end up with something like this, like 4 equals 4, just like we did with substitution. So we know that that's infinitely many solutions, or if we end up and our variables all wipe out, we end up with something like this that we know isn't true, that would be a no solution. So we're going to move on to our story problems. So our first story problem says the sum of two numbers is 70. Since we've been using x and y, we're going to have our two numbers called x and y. Number is usually means equals, so x plus y is equal to 70. And then it says the difference of those two numbers, so sum means to add, difference means to subtract. So the difference between those two numbers equals 24. So now we have a great situation for elimination. So our y's are going to cancel out. Plus y and minus y wipe each other out. X plus x is 2x's. And then 70 plus 24 is 94. And if I divide both of those by 2, I end up with 47. So there's my x. And then my y value, I'm going to plug it in either one of these. I'm going to go ahead and do this one because that's more positive. So it says x. We know x is 47. Plus y is 70. So we're going to subtract 47 from both sides. So y is going to end up being 23. So when x is 47 and y is 23, that will give us a sum of 70. And if I subtract those two, I will end up with a difference of 24. So that one does work. So number 12, now remember we're supposed to show these using elimination. Our first part here says the sum of two numbers is 70, so exactly like what we did in our first equation to the left. And then our next one says one number, so let's say x. I'm going to put this over here. So x is means equals, and then it says 10 more than twice the other number. So that'd be 10 more than twice. The other number would be y. Well, this would be great for substitution, but we're supposed to use elimination. So I'm going to move this 2y over here. So I have 10 equals x minus 2y. And then I can combine that over here with my other equation, and that allows me to use elimination a lot easier. Now I want to be able to eliminate, and I'm really close to being able to do that, but I have a positive, both of them are positive x's. So I'm going to go ahead and change everything on the bottom. I'm taking everything here times -1. So my bottom problem now looks like that. Now I'm going to combine everything. So my x's wipe out, and then I have a y and 2y, which is 3y, equals 70 plus -10 is 60. So y would equal 20. So I'm going to take that y, and I could either put it in here, I could put it in here, or I could even put it in that equation. So I'm going to go ahead and put it in that first equation because I see that that's going to solve for x right off the bat. And I'm going to take, so I'm using this one right here. So I'm going to take 2 times whatever y is. I found out y was 20. And then I'm going to add 10. So we have x equals 40 plus 10, or x equals 50. So my two numbers are 20 and 50, and I can test it out up here by putting in 50 for x, 20 for y, and I do get 70.